This is a very basic introductory chapter on how you correlate data sets, right? So suppose you have a given data set. How can you have a given data set for any given linear regression? If it is two variable problem, you have one independent variable and you have one dependent variable. So how many dimensions will you have in your graph?
Two dimensions.
Two dimensions, right? So if you have a two-dimensional data, you have an independent variable set and the corresponding dependent variable set. That is x1, x2, x1, y1, x2, y2, x3, y3, and so on and so forth. So now any given random data, any set of data, if you fit it into a best fit linear curve, by linear curve, I mean it is a straight line. And what is the equation of straight line? It is of the form y equals to mx plus c, where m is your slope and c is your intercept, right? So something like this, right? If you have all these random data sets, x1, y1, x2, y2, and all these data sets, then if you fit a best fit curve of this form, then we say that we are doing linear regression. Why linear? Because it is a straight line. If it would have been a curve, a 2-degree or 3-degree polynomial, we say polynomial regression. So far, so clear? Is there any doubt?
No doubt.
Okay. So that means now for linear regression, I just want to understand, what do you mean by regression? Is there anyone who understands what is regression? What is the definition of this line? There can be n number of lines which I can draw through this data set. What is unique about this particular line?
Distance from every singular point is minimum.
Distance from every singular point is minimum. Exactly. So what he means, I will just elaborate. Okay, so what this line stands for is that particular line wherein the distance from that corresponding point to a given point, if you add it all up, this is going to be the minimum. I'll repeat again. See, this is your data set, given data set xi, yi, and this is your best fit curve line which fits into this equation. So if you put this xi point, xi variable in this equation, you will get a y hat I, which is different from your yi. That means at the same xi, which is, say, suppose this value, your yi is this point and y hat I is here on this line, because essentially this equation will be satisfied at every point of this line, right? So for the same xi, you have a point yi which is given to you in the given data set, which has some errors, and there is a best fit curve on which this xi will correspond to a point xi y hat I. Okay, so that means there will be a difference between your points yi and y hat I. That difference for each of the points, if you see and add it up, that will give you the total error of the data set. So far clear?
Yes.
Okay. Now, if I just blatantly take all of this data set and add it all up, do you realize that adding this all up will maybe nullify the effect of the positive errors and the negative errors? See, if I take, say, suppose yi minus y hat I, then this value will become a positive value and this distance will give a negative value. So the algebraic sum will yield a very lesser value as compared to the actual sum of each of the moduli. Can you realize that?
Yes, ma'am. Yes.
Is there anyone who has not been able to catch what I just said?
Ma'am, can you explain again?
Okay. just look at this red line and look at this red line. Okay, so this is the positive error. If I take yi minus y hat I, which is yi minus y hat I, this red value will give a magnitude which will be positive, and this red line will give a magnitude which is negative, right? So if I algebraically just sum up all of these vertical lines, just imagine that there are all these vertical lines. I have just drawn three for the sake of clarity. So all of these lines, if I just algebraically sum it, the positives may nullify the negatives. So overall, I may get zero error. It is possible, right? But essentially, my error is not zero. You can realize that from this. All of the points are not lying on the straight line. If they had been lying on the straight line, then only the error is zero. Otherwise, it's not, right? So the first thing which we need to do is to take the magnitudes only, not the algebraic sum, but the root mean square sum. We will come into the details later, but for now, just for the sake of understanding, just understand that you will take yi minus y hat I whole square as the value of your error, which is this. Can you see that? This is your expression. Now, since it is a square term, it can never be negative, right? So you can just add it all up and it will give you a positive value of error. This, summation signifies the addition. Can you follow me so far?
Yes, ma'am.
Okay. So each individual line is the error small e, and if you sum it all up for all the data sets, it gives you the capital E function, which is the error function, which is nothing but the summation of each individual value. Okay. So now, what is the sole purpose of linear regression? This regression line is the best fit curve. So in order to be the best fit curve, you need to minimize this error. So you have defined a function and you want to minimize it. So what are you looking for essentially for this function?
Total error should be less and
Not less, it should be least. And when
least
does that happen?
when
Differentiation.
when all points lie on that line or nearby
No,
the
no,
line.
this you cannot change. This is, you are supposed to assume that this is your given question. You cannot change the question. These are your given data sets, these points, these blue points. You cannot change that. Now,
This curve should be like that. It should covering all the points.
no, not
Sir,
really. Then
we
how
can,
is it a straight line?
So we
ma'am,
need
we
to
can
find some
change
other
the
straight
state.
line.
You have to find the best fit straight line, wherein the sum of the errors is minimum.
We have to normalize the entire.
Are you aware of the concept of maxima and minima? Anyone?
Yes, ma'am.
Yeah.
Yeah.
No, ma'am.
So, okay, minima.
Differentiation.
Exactly. You need to differentiate this expression. And after that, what do you need to do for that
Equal to
expression?
0.
Equal to 0. So if you want to find any given function, for any given function, if you want to find what is the minima or maxima, the first thing you will do is you will differentiate it and equate it to 0. At your minima or maxima, your differentiation will be 0. Okay, it has to be for any given function. This is not the function which is this. The straight line is the expression this, y equal to mx plus c. Do not confuse this expression and this expression. This equation of this line is not this error function. You need to minimize the error, not the straight line. Understand? So this error function you need to minimize, differentiate it and equate it to 0. Do you understand? You are not supposed to
Yes,
take a
ma'am.
differentiation of this. Okay. So now that you have defined this function, you are supposed to take a derivative of this with respect to the parameters of the equation. So we will go ahead with that. So firstly, we will expand this expression. Okay. And after expanding this expression, we will take a derivative with respect to the parameters. What are our parameters here? M and C, because x and y are the variables. Okay, is this understandable till here?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Okay, good. So then we go ahead and expand it. So what did I say? This y hat I is nothing but this mx plus c. If you take it for an ith term, so it will be mxi plus c, right? So I will simply expand it, this y hat I, into mx plus c, and the rest remains same. Is this understandable till here? Nothing, I've just expanded
Yes, ma'am.
the term. Okay, good. So now that you've expanded this term, you are supposed to take a derivative of this with respect to firstly m, then secondly c. So with respect to m, if I take a derivative, then this is the expression which I get, and I equate it to 0. So finally, what do I get? Something like this. An expression which is something like this. Is there anyone who is not able to follow this part?
Yes, ma'am. मैम कैसे हुआ ये वाला नहीं समझा.
Ma'am, can you please explain it again?
Okay, I will go back again. Here I have just taken the error function and I have expanded it. You have this best fit linear curve. Assume it to be y hat equals to mx hat plus c. Okay. So for this best fit curve, you know that your error will be minimum. Your error function, this is your error function, it will be minimum. Okay. And your y hat I is nothing but something which stands for this expression. That means mx hat I plus c. I is nothing but your subscript which corresponds to the number of your terms. So suppose this is your first term, second, third, fourth, fifth, like that, so on and so forth. So I is just that number, the sequence number. Do not confuse it with your variable. Okay. So you understand the difference between yi and y hat I, right? So for any given xi, say suppose I'm considering this xi. This is which one? 1, 2, 3, 4, 5, 6. Yeah. So x sixth. I is your 6. So for x6, you have a y6, which is your given data set, and you have this y hat 6, which is your predicted linear regression curves value for x6. Can you follow me? What is y and what is y hat?
Yeah, it's clear.
मैम मैम ये वाला ठीक है मैम. इसके आगे वाले स्टेप में प्रॉब्लम.
हाँ. So इसके आगे वाला स्टेप अगर आप देखेंगे तो I have this error का expression, right? So in this error का expression, I'm just simply substituting this y hat I because this belongs to this equation, right? Y hat is this equation. So इस value को मैंने बस expand किया है. y hat को replace करके मैंने mx plus c लिखा है. mx hat plus c वही किया है. Oh, I missed the hat. Sorry. यहाँ तक clear है ना?
हाँ मैम यहाँ तक क्लियर है.
Yes, ma'am.
Okay, good. So now that you have this, अब इस error function को
Ma'am,
मुझे
why should we differentiate with respect to m?
yes, because those are the parameters. See, if you have to differentiate, you cannot differentiate it with the variables itself, right? Because those are the ones you're computing it with. If you differentiate it with respect to m, you will get an expression in terms of y and x. If you differentiate it with respect to c, you will get an expression with respect to y and x, right? If you differentiate with respect to x and y, you will get a variable an expression in terms of m and c. Hello.
Yes, ma'am.
So
Yes,
ma'am. You have to differentiate what are your unknowns and what are your knowns. This should be distinguished, right? Your knowns are your x and y's. Those are your knowns. You need to find out the m and c so that you can, write this equation, this expression, any equation, right?
So ma'am, basically we are trying to find out the best equation of the line which will have minimum distance with all the points.
Exactly. That is what your linear regression means. See, you can, through this data set, I can have infinite number of lines, right? Any line can pass through this data set. So what is unique about this line? Why is this the regression line? Because here the error is minimum. This is the best fit line that you can fit through this data set. Do you understand it now? Error is
Yes, ma'am.
Yes, ma'am.
right. So that is unique about this line. Otherwise, you can draw infinite lines through this. Okay. So to minimize the error, we have defined the error function as a summation of each individual errors, and we will expand that function and differentiate it because we have to minimize it. So differentiate it and and equate that expression to 0. So that is what I've done here. The first differentiation will be with respect to your first parameter, which is m. Another differentiation will be with respect to the second parameter, which is c. So now you have an expression in both of these variables. So for any system of equations, I hope you're aware of system of equations, right? So for any given number of unknowns, how many equations do you have? For example, if you have, say, n variables to find, so how many equations do you need to solve it?
And
N.
N, exactly. So if I have two unknowns, which is m and c, then I need two system of equations in order to predict, or not predict, in order to calculate what is your m and what is your c, right?
मैम एक और बार बताओ.
Okay. So you have two variables. You have to find this best fit curve, right? This best fit line. So for this best fit line, you need to find m and c. So how many unknowns are there? Two unknowns are there.
Two
So,
unknowns.
so how many equations do you need to solve this?
Two equations.
Two
Minimum
equations.
two.
Okay. Now suppose instead of drawing the straight line, I want to fit a best fit polynomial of n degree. So how many parameters will I be having?
N parameters.
N parameters. There will be n minus 1 coefficients, and there will be a constant term, right? So for example, if my degree is 3, for example, a 3-degree polynomial, if I want to fit here, so what will be my expression? Y equal to m1 x cube plus m2 x square plus m3 x plus a constant term. So how many do we have?
4. 3 plus 1.
3 plus 1, 4. So for a cubic polynomial, you will have to, I had said n, right? Should be n plus 1. So for a cubic polynomial, you have n plus 1, that is 4 variables to find out, m1, m2, m3 and c. And for those 4 variables, you need at least 4 equations to solve that. Okay. So if you
Yes,
calculate the error in that case, that expression, if you substitute here for a cubic polynomial, and if you calculate the error, you will see with respect to those 4 parameters, you will have 4 different equations to solve. And from those 4 equations, you can find those unique set of variables m1, m2, m3 and c. So let us keep it simple for now. We have a linear 1-degree polynomial case, and for that we have two parameters, and we need 2 system of equations to solve these 2 parameters. Is this clear?
Yes, ma'am.
Yeah, it's clear.
Yes. So with respect to m, when we differentiate, we get this expression after equating it to 0. And with respect to c, the second parameter, when we differentiate, we get and equate it to 0, we get this equation. And why did we choose to differentiate with respect to m and c? Because we need to find out m and c. M and c are the unknowns, while x and y data sets are your known data set. So you have to differentiate with respect to the unknowns to get an expression in terms of the unknowns. Okay.
ma'am, should it be xi cap?
Yes, you can write it xi cap. It doesn't matter. I hope you have understood the difference between the hat and the without hat expression, right?
Yes.
Okay. So
हम
okay.
हैट वाला प्रेडिक्शन होता है.
Yes, hat वाला prediction है या calculated value है which fits in this equation. It has to lie on this line so it has to satisfy this equation. Lekin these values do not essentially lie on the line, so they will not satisfy this equation. Only those points which lie on this line will exactly satisfy this equation, and in that case this error will also be zero. For example, if you see this point lies on this line, right? So my yi and y hat I are same, so your error for this point will be zero. All those points which lie on this line, unke liye the error will be zero. Can you follow me so far?
Yes,
Yes,
ma'am.
ma'am.
Yes,
Okay,
ma'am.
good. So now that you've understood this, I just let me know if this differentiation is not clear. I hope you are aware of differentiation. You've gone through basic calculus, right? All of you.
Yes, ma'am.
Yeah. So I'm not going
Yes,
into
ma'am.
details of that. So now that you've got these two expressions, what do you see? What are the things that you need from your data set? Because you have your xi and yi data set, right? So now that you have your data set for xi and yi, what are the things that you need? The summation of xi square, the summation of xi, the summation of xi and yi products, the summation of xi again, so it is the same value. The total number of data set that you have, it depends on what is your data set actually, and what is this summation of yi. So basically you need the number of data set, then secondly summation xi, summation yi, summation xi square, and summation xi yi. These five things you need, right? So now that you've understood this, acha, one more thing. Do you remember in the previous slide I said that we have to get these equations, and these equations can be found from the error function, and this error function that I said is the summation of the squares, right? So, and you can take a root of this basically. So what do you, if you see what this is actually root mean square. This is called RMS, root mean square. Okay, and you need to minimize this root mean square. What I have defined here is the root mean square function. I forgot to put a square, but anyway, if you minimize this function, the square root will automatically be minimized, so you can ignore that. So we will go backwards actually. It says root mean square, just go reverse. The first square it, then take an average of it, and then take a square root of it. Okay, so that is what you
मैम
mean by.
ये सम ऑफ स्क्वायर जैसा होता है या
Sorry,
उसका अलग है? मैम सम ऑफ स्क्वायर जैसा है या कुछ और है?
sum of squares की तरह ही
Like
है.
for-
Okay, this is sum of
Okay.
squares. You've taken a term and you've taken a square of the term, and you've taken the summation of all those squares, right? So basically,
Okay.
if you see this, it is y hat 1 minus y1 ka square plus y hat 2 minus y2 ka square plus y hat 3 minus y3 ka square, and so on and so forth till y hat n minus yn whole square. Okay, so this term expands like that. I hope this is
So
clear.
that means this summation goes from I equal to 1 to n. That's
Yeah,
why
exactly.
n came into the second in the second differentiation.
Exactly.
Del E by del C.
Exactly. Yeah.
That's okay.
Okay. Is there any other doubt here in this slide?
Yes,
Yes, ma'am.
please go.
Okay. So now that you've understood this, I just wanted, like we discussed in the previous slide, that you cannot take the algebraic sum of these values because they may essentially nullify each other. So what are you supposed to do? You are supposed to take the magnitude. One way of taking the magnitude is either you take a modulus of that. You understand what is modulus, right? A straight line, straight vertical line, two straight vertical lines in which you enclose your number. But modulus has
Yes,
no
ma'am.
expression defined. So it will be very difficult to compute the differentiation terms. You cannot do that. So instead of that, what you can do is you take a square of it. Okay, you take a square of it. Now you are sure that anyway, if it is positive or negative, the square of it will automatically be your positive value. So this thing you ensured by taking a square. Now what you do again, you've taken the square. Now what you want is the summation of all those squares, because you want to sum up all the errors. Okay, so you took a summation. Now what you do, since you had taken a square, so you take a square root to nullify the what do I say, exaggeration of the value, the exaggeration of the error. So for example, if you have an error of 2, and if you take a square, then basically it will become 4, right? So just to nullify that, since you had taken a square initially and you had then taken the summation, so you will just, after taking the summation, you can take a square root. But then again, you must understand that an error function wherein you have a square root term, if that is minimized, then without the square root also it will be the minimized function, right? So it is immaterial whether you put a square root or not, but you have to minimize this expression. Do you understand now?
Yes,
Yeah,
ma'am.
it's clear, ma'am.
Okay, good. So now that this RMS is clear, we will move to the next slide. This is an example of your data set. So suppose you have 4 data sets. This is a very simple data set. You can have n number of values. You can have thousands of data to handle. You can use Excel sheets to handle this data. So you have a given table to you, and you have your x and y data sets. So your points are 2 comma 3, 4 comma 7, 6 comma 5, and 8 comma 10 on your Cartesian curve, Cartesian plane. If you see, these are your 4 points. So you have 4 scattered points. Now you want to draw a straight line through all of these points such that your error is minimum, your best fit straight line you want to draw. So what are the things that you need? You need to find out xi. You need to tabulate the xi, so which is already given. So what you need to do is summation of xi. Again, you need a total number of terms, that is 4 in this example. You need summation of yi. Again, your yi is known already, so you just need a summation of this. And you also need your xi square. So you need to basically add one more column here and take a square of all of these. Okay, and then sum it all up. So that will be it. And then you need another column which is xi yi. So you need another column which is a product of these two, and then you need to sum it up. So basically this is your table that you will have. So far so good?
Yes, ma'am.
Yes, ma'am.
Okay, so now in this table I will just put the computed values. Can you follow this so far?
Yeah.
Yes, ma'am.
Yes,
Okay,
ma'am.
so now that you have these data sets, what you need to do is just plug in these values into these equations. We have these two equations. We have these values right now, all of these values, except m and c, everything is plugged into this equation, and we will have two sets of linear equations in two variables to solve. So that is this and this. Can you follow this?
Yeah.
Yes, ma'am.
Yes, ma'am.
Okay, good. So now you have these two equations. You have two variables m and c, and if you solve it, you get m equals to this and c equals to this. Now you can define a straight line equation which is of the form y equal to mx plus c, which is the best fit curve to fit this given data set, where the error is minimized, the least error. This is your straight line, y equal to 0.95x plus 1.5. Is this understandable?
मैम कैसे होगा ये?
You
मतलब ये
got
0.9 पर ये y कैसे हुआ?
y कैसे हुआ?
मैम अभी आपने बोला ना कि ये y हुआ.
Just solve
नहीं
two
समझा
equations. That's all. You will get two values m and c if you solve these two
आपको
equations.
चाहिए क्या? m और c की वैल्यू चाहिए थी ना इस इक्वेशन के लिए. ये स्टार्टिंग में ये इक्वेशन था हमारा, y इक्वल टू mx
हाँ
प्लस
हाँ
c.
हाँ हाँ.
नाउ आपको एक स्ट्रेट लाइन का इक्वेशन चाहिए जहाँ पे m एंड c आर अननोन. अभी हमने m और c को कैलकुलेट कर लिया गिवन डेटा सेट से. सो नाउ यू हैव दिस एक्सप्रेशन ना. What is your m? 0.95. What is your c? 1.5. So now you can plug in those values of m and c and you will get your whole expression. the equation of the straight line. The equation of the straight line is y equal to 0.95x plus 1.5. That is your equation of this straight line.
Okay,
Not
ma'am.
the
Okay.
straight line, that straight line for that data set. This is just an example here. I'm talking of this example. अनलाइक जो मेरा एग्जांपल स्टार्टिंग में है जहाँ पे यू हैव एन नंबर ऑफ पॉइंट्स, यहाँ पे ज्यादा पॉइंट्स हैं. जस्ट इमेजिन देयर आर 4 पॉइंट्स हियर समवेयर एंड यू हैव दिस बेस्ट फिट कर्व. तो वैसा एक एग्जांपल है. क्लियर? अरे क्लियर है?
समझ गया.
ओके.
हाँ मैम.
Madam, actually, what is the difference? Mean square error and root mean square error, madam. What is
या
difference?
देखिए आपका एरर का एक्चुअली एसेंशियली जो हम कंप्यूट कर रहे हैं ना, दिस इज मीन स्क्वायर एरर. दिस इज नॉट रूट मीन स्क्वायर, क्योंकि आप उल्टा जाइए. देखिए पहले आप क्या करें, स्क्वायर कर रहे हैं एरर को. व्हाई आर यू डूइंग द स्क्वायर? बिकॉज आप एल्जेब्राइक सम लेंगे तो वो एक दूसरे को कैंसल आउट कर देगा, राइट? इट विल नलिफाई द इफेक्ट. ये पॉजिटिव है, ये नेगेटिव है. हम अलजेब्राइक सम लेंगे तो मे बी इफेक्टिवली एरर मिनिमाइज्ड हो जाएगा, ये जीरो हो जाएगा. आई डोंट वांट दैट. आई वांट ईच एरर का मैग्नीट्यूड. फॉर दैट मैंने क्या किया, स्क्वायर कर दिया. सो स्क्वायर इसेंशियली मीन्स कि ये पॉजिटिव है तो भी प्लस रहेगा, नेगेटिव है तो भी प्लस रहेगा, राइट? सो नाउ इफ आई सम इट ऑल अप, उस स्क्वायर वाले सारे टर्म्स को इफ आई एड इट ऑल अप, नाउ व्हाट डू आई हैव? द सम ऑफ द स्क्वायर्स ऑफ द एरर्स, राइट? अभी आरएमएस था ना, आप उसको उल्टा पढ़िए. देखिए स्क्वायर लिया, फिर उसको ऐड किया. अभी क्या करना है, उसका रूट लेना है, राइट? तो उसका रूट नहीं लिया है यहाँ पे हमने. वही मैंने जस्टिफाई किया. अगर आपने रूट भी लिया होता और उस फंक्शन को आप मिनिमाइज करते तो भी m और c वाले की सेम वैल्यू आती, क्योंकि आप किसी नंबर को मिनिमाइज, किसी फंक्शन को मिनिमाइज करिए या उस फंक्शन के स्क्वायर को मिनिमाइज करिए, एक ही बात है. अंडरस्टूड? इफ
Yes, yes, yes.
if suppose my error, if my error square was 4, which is the minimum value, then if I take a square root of it, then it will be the error of 2. वही minimum value होगा. बिकॉज द कंपेरिजन चेंजेस ना. अगर मैंने ये स्क्वायर रूट लगाया है तो मैं सारे स्क्वायर रूट एरर्स को ही कंपेयर करूंगी. अगर मैंने स्क्वायर रूट नहीं लगाया है तो मैं सारे स्क्वायर्ड वाले ही समेशंस को कंसिडर करूंगी, है ना? सो इन आइदर ऑफ द सिनेरियोज आप फंक्शन चाहे रूट लगा के लें या बिना रूट लगा के लें, आप मिनिमाइज करेंगे तो आपको सेम एक्सप्रेशन आएगा, राइट?
So, ma'am, excuse me, ma'am. So we can take any equation.
You can take a square root after the summation, but that is just going to complicate things. आपको basically तब आप क्या करोगे?
The value will be more, ma'am. Right?
नहीं, value will not be more. The expression will be more complicated. आपको solve करने में. और what else people do is actually, अगर आपने error को define किया है ना कि square root है, तो आप एक काम करो, instead of minimizing the error, आप error के square को minimize करो, है ना? तो आपके लिए लाइफ इजी हो जाएगी. आप ऐसा समझो कि ये एरर नहीं है, ये एरर फंक्शन नहीं है, एरर का स्क्वायर फंक्शन है, क्योंकि एरर तो आपका रूट मीन स्क्वायर है ना? तो अभी ये ई के बदले आप समझ लो यहाँ पे ई स्क्वायर लिखा हुआ है, तो आप ई को मिनिमाइज करोगे तो आप ई स्क्वायर को भी मिनिमाइज करोगे, है ना?
So here we are taking, ma'am, root mean square, right?
Yes.
Root, yeah, only sum of square we are taking, ma'am.
So it is mean square, not root mean square. But अगर मैं इसको e square लिख दूं, then my e is root mean square.
हाँ.
है ना?
Ma'am, one more thing, that in a second equation we are getting like differentiating with respect to c. Here we are getting c multiply with n, that
Right.
number of data. It is how we are getting n here, ma'am.
अच्छा, अभी ये समेशन टर्म बाहर है ना?
हाँ.
अभी आप हर एक्सप्रेशन में इसको डालोगे, है ना? तो आपका जो m है वो तो बाहर आ गया, 2 भी कांस्टेंट है वो बाहर आ गया, लेकिन xi क्या है? मल्टीपल वेरिएबल्स हैं आपके, है ना? तो समेशन ऑफ xi आया. अभी यहाँ पे ना x है ना y है, तो बेसिकली क्या है? यहाँ 1 है, राइट? 1 है, c मल्टीप्लाइड बाय 1. c तो आपका कांस्टेंट है, बाहर आ गया. और समेशन ऑफ 1 हाउ मेनी टाइम्स? जितने टाइम समेशन है i इक्वल्स टू 1 से i इक्वल्स टू n तक है ना? तो उसको आप 1 को n टाइम्स ऐड करोगे तो आपको n आएगा.
ओके मैम, थैंक यू मैम.
ओके, और कोई डाउट?
वेरी वेल एक्सप्लेन्ड मैम. You are explaining very nicely,
हाँ,
ma'am. Each
thank
and
you,
every doubt you are clearing, ma'am. Thanks a lot.
थैंक यू। और कोई डाउट, एनीवन?
अभी तक
No,
नहीं।
ma'am.
नो मैम।
Good. So now that you have this example, you understood कि कैसे कैलकुलेट करना है एंड कैसे बेस्ट फिट कर्व निकालना है। सो दिस इज अ सिंपल एग्जांपल, हमने लीनियर कर्व लिया है। आपके साथ क्या होगा, अगर आपको लीनियर कर्व की जगह n डिग्री पॉलिनोमियल होगा तो आपके n नंबर ऑफ एक्सप्रेशंस होंगे। तो वो n नंबर ऑफ एक्सप्रेशंस ऐसा क्या है कि अगर 3 डिग्री या मैक्सिमम 4 डिग्री तक भी है तो लोग मैन्युअली कैलकुलेट कर सकते हैं, बट अदरवाइज अगर ज़्यादा नंबर ऑफ सिस्टम ऑफ इक्वेशंस है, n नंबर ऑफ सिस्टम ऑफ इक्वेशंस है, तो लोग मेक यूज ऑफ कंप्यूटर्स एंड कोडिंग सो दैट आपके सारे वेरिएबल्स की वैल्यू वो कंप्यूट हो सके। ओके, देयर इज दिस बेसिक डिफरेंस, और कुछ ऐसा डिफरेंस नहीं है। यू कैन डू इट फॉर लाइन ऑल्सो, यू कैन डू इट फॉर एनी डिग्री पॉलिनोमियल। 2 डिग्री पॉलिनोमियल एक पैराबोला होगा, 3 डिग्री पॉलिनोमियल आपका हो सकता है, 4 डिग्री पॉलिनोमियल, इट डिपेंड्स कि आपका कौन सा किस तरह का कर्व आप फिट करना चाह रहे हो। यूजुअली अगर आप लीनियर फिटिंग कर रहे हो, जो कि मोस्टली लोग करते हैं, इन दैट केस दिस इज द फॉर्मेट जो आप फॉलो करोगे। सो व्हाट यू विल हैव, ये 4 तो नहीं होगा, मे बी 4000 हो सकता है, या मशीन लर्निंग में और भी ज़्यादा डेटा सेट्स हो सकता है। उनको हैंडल करने के लिए यू विल यूज़ एक्सेल शीट। आपको ये गिवन डेटा ऑलरेडी है, 4000 सपोज डेटा सेट है आपका एक्स और वाई का, तो आपको और क्या करना है, 2 कॉलम्स बनाने हैं, और जिसमें सेकेंड कॉलम में आप फॉर्मूला डालोगे स्क्वायर का फर्स्ट कॉलम के लिए, सॉरी थर्ड कॉलम में डालोगे फर्स्ट कॉलम का स्क्वायर, और फोर्थ कॉलम जो आप बनाओगे उसमें आप प्रोडक्ट डालोगे फर्स्ट और सेकेंड कॉलम का। ये आपको करना है। फिर लास्ट में जाके आपको क्या करना है, इन सारों को ऐड अप कर देना है, इन सारों को भी ऐड कर देना है, और ये तो एडेड था ही। तो आपके पास टोटल वैल्यूज हो जाएंगी जो आपको प्लग इन करना है इस इक्वेशन में, एंड देन यू फाइनली हैव दिस पैरामीटर का वैल्यू टू फिट योर बेस्ट फिट, to give your best fit curve का
Yes,
equation.
ma'am. Yes, ma'am.
Okay.
Ma'am, sorry to disturb you again, ma'am.
हाँ.
Ma'am, in equation we are getting 2 also. 2 multiply summation of
हाँ,
2.
हाँ.
Then where is 2 now, ma'am? We are not using anywhere in the
आप
equation.
डिफरेंशिएशन जब आप एक बार रिवाइज करना, अगर आप डिफरेंशिएट कर रहे हो किसी चीज को, ठीक है, तो जो पावर में है ना,
हाँ,
वो
वो
मल्टीप्लाई होगा,
multiply हो जाता है, मैम,
है
राइट?
ना, और इसका पावर एक कम हो जाता है, तो वही किया है यहाँ पे, है ना।
ये तो
ये किया,
after that,
अब
हाँ,
इस एक्सप्रेशन का ये हुआ, लेकिन
हाँ,
हमने डिफरेंशिएट किसके रिस्पेक्ट में किया है, m के रिस्पेक्ट
m
में,
के
तो
respect
कोफिशिएंट
में,
क्या मल्टीप्लाई हो जाएगा, xi,
हाँ,
है ना। तो
हाँ,
आप ऐसा समझिए कि ये एक्सप्रेशन ऐसा लिखा हुआ है कि हमारा इस टोटल को आप मान लीजिए एक अल्फा, अल्फा को आप डिफरेंशिएट कर, सॉरी अल्फा स्क्वायर को आप डिफरेंशिएट कर रहे
डिफरेंशिएट
हैं,
करें,
तो
हाँ,
आप क्या होगा, वो 2 अल्फा हो
2
जाएगा,
अल्फा,
ठीक
राइट,
है, तो वो 2 अल्फा ये हो गया।
हाँ,
लेकिन आपका डिफरेंशिएशन अल्फा के रिस्पेक्ट में तो नहीं है, किसके रिस्पेक्ट में, m के,
m
तो m का क्या कोफिशिएंट है, ये
xi है, मैम, हाँ,
तो वो मल्टीप्लाई हो जाएगा। ये सिंपल डिफरेंशिएशन है, यहाँ पे भी यही है। c का क्या कोफिशिएंट है, 1, सो बेसिकली इस डिफरेंशिएशन के साथ एक मल्टीप्लिकेशन है।
ठीक है, मैम, ठीक है।
Ma'am, if we go for polynomial kind of equations, does it mean that we are overfitting the data?
नो, नॉट रियली। ओवरफिटिंग अंडरफिटिंग का यहाँ पे बात ही नहीं है। यहाँ तो आप डिफरेंशिएशन कर रहे हैं, यहाँ फिटिंग नहीं हो रहा है डेटा का, आप बेस्ट फिट कर्व ही निकालते हैं मैथमेटिकली जो
No, ma'am, I'm talking about if we take for polynomial, y hat is polynomial.
हाँ हाँ,
Isn't it overfitting the data?
no, that depends on your data. वो you cannot see and say. There is a term actually which is called I think it is called regression coefficient, ठीक है। So that basically tells you what is the degree of fitting, how good fit you have, goodness of fit, राइट। तो उससे आप बता सकते हो कि गुडनेस ऑफ फिट अगर रिड्यूस कर रहा है तो आप अंडर फिट या ओवर फिट कर रहे हो, वो आपको कंपेयर करना पड़ेगा, बट दैट इंट्रिकेसीज में अभी जाएंगे नहीं। फॉर द सेक ऑफ अंडरस्टैंडिंग जस्ट अज्यूम कि क्वेश्चन में ये बताया हुआ है कि यू हैव टू फिट अ लीनियर कर्व। अगर आपको चूज करना है कि लाइन फिट करूं या पॉलिनोमियल कोई डिग्री का फिट करूं, इन दैट केस आपको सारे फिटिंग करने होंगे, वो सारे कैलकुलेशंस करने होंगे। जैसे कि फर्स्टली लाइन में फिट किया तो हमें m एंड c मिला, पैराबोला में फिट किया तो m1 m2 और c मिला, 3 डिग्री पॉलिनोमियल में फिट किया तो m1 m2 m3 c मिला। ऐसे करके हम लोग बहुत सारे, यस
कुछ लोग इंग्लिश में एक्सप्लेन करने के लिए बोल रहे हैं.
Okay, I'm so sorry. So assume that it is specified in the question that you have to fit this given data set in a linear form for the sake of simplicity. In that case, you don't need to find the goodness of fit, because you need to find the goodness of fit, how good your fit is, only when you have your you have to choose whether or not this data set, suppose you have this data set and you don't know whether it should fit a line, or whether it should fit a parabola, or which is a 2-degree polynomial, or whether it should fit a 3-degree polynomial, or whether it should fit a 4-degree polynomial, whether it should have a logarithmic curve, whatever it is, you don't know. In that case, you have to do this trial and error. You have to fit this into the line and then see what is the goodness of it. Again, you have to fit it into a parabola and then see what is the goodness of it. And similarly, you can do it for n number of trials, and then you can see कि goodness of fit कहाँ पे सबसे अच्छा आ रहा है. That is your best fit line or best fit polynomial. All others are either underfit or overfit. Okay, वहाँ पे there is this concept of underfitting or overfitting. यहाँ पे फॉर द सेक ऑफ सिंप्लिसिटी यू अज्यूम कि आपको ये जो गिवन डेटा सेट है उसमें दिया ही हुआ है कि आपको ये बेस्ट फिट लाइन में फिट करना है. इन दैट केस यू डोंट नीड टू फिगर आउट कि आपको लाइन में फिट करना है या किसी और कर्व में फिट करना है. सॉरी, इन दैट केस यू डोंट नीड टू फाइंड आउट whether or not you need to fit it into a linear form or in the form of some other polynomial of nth degree. Okay, तो यहाँ पे
Yes,
here
ma'am,
you do
it is
not have
clear.
this concept of underfitting or overfitting. That comes only when you have to compare amongst different curves. For a given curve where there is no such comparison, there is no such concept of underfitting or overfitting. You are just fitting a best fit line wherein this error sum is minimized. And how can you minimize this? By simply differentiating, equating it to 0, and then figuring out what are your parameters. Okay.
Excuse me, ma'am. Are we calculate y for every corresponding y instances?
Sorry, I couldn't understand your question. Could you repeat?
Ma'am, are we calculate y for every instances?
Yes, of course. Yes, of course.
Okay.
For every value, every I,
Yes,
where
ma'am.
I equals to 1 to n, you need to find out what is your y hat I. Then only you will be
Okay.
able to find the individual errors, right?
Okay. Thank
This I'm just explaining for the sake of understanding, but you don't do this manually. You do this by fitting a formula into your Excel sheet. So it is just a one click, nothing else. You just have
Yes,
to fit a formula and it will itself calculate what is the difference.
Okay.
Okay?
Ma'am, can
so
you
ma'am, we
also-
don't have to मैम एक और चीज पूछना था. मतलब हमें क्या बोलते फॉर्मूला बनाना नहीं पड़ेगा ना, मतलब ऐसा इक्वेशन बनाना नहीं पड़ेगा ना.
इक्वेशन तो बनाना पड़ेगा आपको. ये टेबल देखिए, यू विल गेट दिस टेबल एज द क्वेश्चन. ओके, दिस इज योर क्वेश्चन.
Okay.
गिवन डेटा सेट and you have been told to fit a linear curve, a straight line, which is best fit where the error is minimized least in this given data set. Now assume instead of this 4 data set you have 4000 data set. Okay, so what you will do
Okay.
is this tabulation. यहाँ पे तो you have the first column and second column. Now you make a third column and fourth column, and then you put the summation terms. And those summation terms is the real value that you need, nothing else. These values are not needed. These are just needed to calculate the sum. उसके अलावा these values are not needed. Nothing is needed. This last row, this is your row which is needed. These values to solve the equation.
Okay.
Okay. So for these 5 values that you have, वो आप यूज करके इक्वेशंस डिफाइन करेंगे. दीज आर माय इक्वेशंस. अदरवाइज देयर इज नो रोल. आपको एक्स स्क्वायर नहीं चाहिए, आपको एक्स वाई भी नहीं चाहिए.
Ma'am, can you also cover how do we calculate cost function? Because a similar example has been asked in our side.
Okay, that is very much similar to what you have done here. Regression is similar to what is the estimation of cost function. I will definitely make slides for that in the next class. Now that you requested it, I will do it. Okay. Okay. So I hope there are no such doubts now. Is it clear how I came about this expression?
Yes.
Okay.
Yeah.
So what is my error? यहाँ तक तो ये समझ में आया. My m and c are these. So मेरा y का straight line का equation है y equal to 0.95x plus 1.5. That is my best fit line. यहाँ तक ये समझ में आया. Now what is my error? So you have this error value, right? This was your expression. See, now you figured out what is your m and c, right? You now figured out what is your straight line equation. Now I am saying if additionally you are asked what is the error, we are saying error is minimized, but that error will have some value, right? Whatever value, that will be minimum, but that will have some value, right? So that error, if you are supposed to find out, if there is a question which is asked to you, what is the error, minimum error? In that case, again, your error expression has this m and c, which you've already found out. So now it is just a matter of calculation. You have these xi, yi terms already in your table. You just need to make another column, and you can just write this expression and then take a square of that, and then at last you just sum it all up. The summation term will give you the error. Is this part clear?
So, ma'am, we do not need to take square root for error, right? Like we
You
were
have to
discussing.
actually, if you actually have to, this again I'm repeating, since error actually is defined as root mean square. So essentially I should have, after this summation, outside the summation I should have a big square root,
Square root.
right?
Okay.
So since I have not put this, so you can understand that this function is basically a error square, not error.
Okay.
Okay.
Error
So
square.
if specifically in the question it is asked that you need to find the error, which is the root mean square, then whatever value you get at last after the summation, after summation of that column, you are supposed to take a square root of that to report. That is the
Understood.
reported value,
Thank
not
you.
the squared value. Okay. So far so good.
Also, we need to divide by n, right, ma'am? Root means square.
No. You don't need to divide by n. While taking mean, okay. Mean is nothing but addition of all the terms and then dividing by n, right? So you have to take a division by n, right?
So that is prior square root.
No, that is immaterial. Yes, prior square root, but under your this thing, under your square root. See,
Yeah.
if you take your n within the summation or outside the summation, it is a constant value, right? It is not going to change. Do you understand? If suppose I had just imagine I don't have these terms, I just have summation of 0.95 xi, then whether or not you write 0.95 times summation of xi or you write summation of 0.95 times xi, it is not going to change. Essentially what I'm saying is, if you have 2, 4, 6, 8, suppose you have these x values, then if you want summation of a constant multiplied by x, so it is immaterial whether you write c times summation x or you write summation of cx, right? So similarly, if you have to divide the summation by n, so whether or not you divide it internally here or you divide it after the whole summation, it is immaterial. But yes, if it comes out of the square root, then it will become square root n. So it should be within your square root. See, RMS, again I'm saying backwards. So RMS means you have to square it, you have to take the mean. So in order to take the mean, you don't just have to sum it, you also have to sum and divide it by the number of terms, because that is mean. And then lastly, you need to take that value and take a square root of that. Okay, so you will square all the errors, which is this bracketed term, and then you will sum it all up, and then since it is a mean value, you have to divide it by n, and then finally you have to take an outer square root of this whole term. Okay.
Ma'am, why RMS? Can we take sigma or any other error approximation function?
You can take n number of functions. Essentially, whatever function you take, it will be defined in a similar fashion. Whether or not you divide by n, whether or not you take a square root, essentially all these forms will minimize your e, right? So all of these forms will yield the same value of m and c. That is not going to change. Okay, so if you take, again I'm repeating, see, if you have your e and you want to minimize your e, then basically you are minimizing e square also, square root e also, e divided by n also. Any constant term, any constant term multiplied or divided, or even any form of e in the form of powers, is not going to change the value of m and c, because if you are minimizing your e, you are also minimizing those terms. If you are minimizing e, you are also minimizing 2 times e, you are also minimizing half times e, you are also minimizing square root of e, you are also minimizing e square, right? So if you are minimizing e, then you can take different forms of e and it will still remain the minimum. Do you follow this much?
Yes.
Okay, so for the sake of simplicity, you can omit those constant factors and you can just simply focus on the main part. But if you really want to be very coherent and comprehensive, then yes, RMS is defined as the squared error, taken the mean of that squared error, and then finally the square root of the mean of the squared error. That is RMS, root mean square, if you go by formula. Okay, is this part clear?
Yes. One
Yes,
thing,
ma'am.
when is your next session?
It's every Monday 6 to 7.
Only one day?
Yes, and there's another session. I think on Friday you had another session.
अब मैं आ रही हूँ.
Okay.
Yes. So actually there is a limitation. We have only 100 admissible participants in your Google Meet. So it is on a first come first serve basis. But then we have recordings of the session, and we also have, you can put in your questions, and on whichever date of the week we find time, we just answer those questions through and through. So you can get in touch with that discussion forum also. Yeah, this is my channel. So this is a newly made channel. I have thought of uploading things here also. Yeah. So yeah, are you able to go to this link? I've just posted it.
Yes, I can access that.
Okay, good. So this is the link you can look for. Today I will not be posting the video. This is my first class, so I will be probably needing more time for editing and coordinating. Maybe in the subsequent lectures it will take lesser time. Probably you can expect a video tomorrow on this channel to be uploaded. Okay,
Yes, ma'am.
so I had few more slides to discuss, but then since it is already time, so we will postpone that for the next session. And also there will be a few more slides for cost function as discussed, so we will cover that in the next class. Okay,
Thank you so much for your session.
Okay, ma'am.
okay.